speed and velocity. Speed and velocity. So we start with speed. What is speed? So the rate of change of position of an object with the time in any of the direction is called speed. So otherwise we can say that the distance traveled by the object in unit time is called speed. So speed is equal to distance traveled by time taken. Okay. Speed is equal to distance traveled by time taken. So the characteristics of speed. Characteristics. 1. Only magnitude. No direction. That is scalar quantity. So only magnitude, no direction, so scalar quantity. 2. Speed may be zero or positive. So never be negative. Okay. Third, SI unit. So meter per second. CGS unit. That is centimeter per second. So these are the characteristics of speed. So speed is equal to distance traveled by time taken. So the characteristics, only magnitude. Speed has only magnitude. It has no direction. So it is a scalar quantity. Speed may be zero or positive. Okay. So never be negative. So SI unit is meter per second and the CGS unit is centimeter per second. Next we are going to see what are the different types of speeds. 1. Uniform speed. 2. Variable speed. 3. Average speed. 4th one, instantaneous speed. Okay, instantaneous speed. Uniform speed, variable speed, average speed and instantaneous speed. What is uniform speed? Suppose a body covers equal distances in equal intervals of time. Okay, equal distances, equal intervals of time. Equal intervals of time. Okay, what is variable speed? Unequal distances in equal intervals of time. So that is called variable speed. So the next is average speed. What is average speed? Average speed. The body undergoing variable speed. So in a particular time interval, the average speed is defined as the ratio of the total distance traveled by total time taken. Okay. So average speed VAV, average speed, is equal to total distance traveled by total time taken. Okay, total time taken. That is equal to x2 minus x1 divided by t2 minus t1. So change in distance divided by change in time. So that is equal to delta x by delta t. So that is average distance, average speed. Okay, average speed. Then the next is instantaneous speed. So the fourth one is instantaneous speed. Instantaneous speed means the speed of the object at any particular instant. Okay, the speed of the object at any of the instant is called instantaneous speed. Otherwise, we can say that the speed of the object at any particular point in its path is called instantaneous speed. So instantaneous speed V is equal to limit delta x limit delta t tends to 0 delta x by delta t, so that's equal to dx by dt. Okay, dx by dt. So this is called what? Instantaneous speed. So instantaneous speed V is equal to limit delta t tends to 0 delta x by delta t, that is equal to dx by dt. So why this delta t tends to 0, how it is delta x by delta t, how it is equal to dx by dt. If you are not thorough this topic means, if you don't know this topic, so the physics 2020, that is mathematical support for physics differentiation part 1. You watched that video. So these are the items I clearly explained in that video. Okay. So V is equal to limit delta t tends to 0 delta x by delta t, that is equal to dx by dt. So that is the instantaneous speed. So the speed of the object at any particular instant, or the speed of the object at any particular point in its path is called what? So instantaneous speed. Okay. Okay, the next is velocity. Velocity. So velocity, what is velocity? The rate of change of displacement is called velocity. Or otherwise we can say that the displacement traveled by the object in unit time is called velocity. So velocity is equal to displacement by time. Okay, displacement by time taken. Okay, time taken. So that is called velocity. So characteristics. So what? So it has magnitude, direction, direction. So it is a vector quantity. Okay, vector quantity. 2. So velocity less than 0, equal to 0, or greater than 0. That point, SI SI unit, meter per second. CGS unit, so centimeter per second. So these are the characteristics of velocity. So velocity has a magnitude and direction, so it is a vector quantity. Velocity may be negative, velocity is equal to 0 or greater than 0. Okay, so SI unit is meter per second, CGS unit is centimeter per second. Okay, so what are the different types of velocity? Uniform velocity, two, variable velocity, third one average velocity, fourth one instantaneous velocity. Okay, these are the four types of velocity. Okay, instantaneous velocity. Okay, uniform velocity, equal displacement. Okay, equal displacement, equal intervals of time, Variable velocity, unequal displacement in equal intervals of time. So that is called variable velocity. So what is average velocity? So average velocity is equal to displacement traveled by time taken. So in a particular time interval, how much displacement the body has traveled. So the displacement traveled divided by time taken. So that is average velocity. So that's equal to x2 minus or r2 minus r1 divided by t2 minus t1. So average velocity VAV vector is equal to delta r vector divided by delta t. So that is the average velocity. Okay, average velocity. So the last one, what is instantaneous velocity? So the instantaneous velocity means the velocity of the body at any particular instant. Okay, particular instant. So V vector is equal to limit delta t tends to 0, delta r vector divided by delta t. So that's equal to dr vector by dt. Okay, dr vector by dt. So that is called instantaneous velocity. So velocity is a vector quantity. Okay, vector quantity. So the vector representation VAV vector is equal to average velocity is equal to delta r vector divided by delta t. So instantaneous velocity V vector is equal to limit delta t tends to 0, delta r vector by delta t. So that is equal to dr vector by dt. So that is called instantaneous velocity. So the next is study on average speed and average velocity. Average velocity. So we are going to make a study on average speed and average velocity. Okay. So average speed. So distance traveled by time taken. So VAV is equal to delta X by delta T. Okay. Average velocity. So displacement by time taken. Okay. VAV vector, okay, is equal to delta R vector by delta T. Okay. 2. Average speed is a scalar quantity. Scalar. So what is the unit? Yes, meter per second. Okay. Average velocity. This is a vector and unit, that is meter per second. Clear? That point. Average speed and average velocity. Both depends on the time interval over which it is defined. Okay. So both depends on time. Both depends on time over which it is defined. That is the third point. Then fourth point. Fourth point. For a given time interval. Okay, for a given time interval. So average speed has multiple values. Average velocity has single value. So you clear this point? Average for a given time interval, average speed has multiple values because average speed is equal to distance by time taken. Distance means it is the path length traversed by the body. So the body can travel in any of the paths. The body can select any of the paths. So average speed has multiple values based on the path it adopted by the body. Okay. Then average velocity is equal to, it has a single value. So whatever may be the journey, from starting point to the end point, we have only one displacement. So average velocity is equal to displacement by time taken. So from the starting point to the end point, we have only one displacement. So average velocity is equal to has a single value. Okay. Then fifth point. After journey, after traveling, if the body comes back to the original position, okay, original position. After traveling, the body comes back to the original position. Then VAV, that is average velocity, is equal to 0, because as delta R vector is equal to 0. Okay, since the displacement is 0, velocity is equal to 0. VAV, that is average speed, greater than 0, as delta S greater than 0. So the distance traveled by the series, the distance traveled by the body greater than 0. So average speed greater than 0. So in this case, average velocity is equal to 0. Why? The displacement is equal to 0. Okay. Then sixth point. In general, VEV, that is average velocity, not equal to VEV. Okay, so that is average speed, because delta S not equal to modulus of delta R vector. Okay, delta R vector. In general, that is average velocity not equal to average speed, because the distance is not equal to the displacement. Okay, distance not equal to the displacement. But sometimes VAV vector is equal to average speed when if the motion is uniform rectilinear motion. Okay, the motion is uniform rectilinear motion. Okay, rectilinear motion. Clear these points? So once again I will repeat, that is for a given time interval, average speed has multiple values. Average velocity has single value, because this is average speed means distance by time. So distance means the path length. So based on the path adopted by the body, so we have multiple values. Average velocity means displacement by time. So in a total journey we have only one displacement. So it's a single value. Okay, if the body comes back to the original position of the journey, that is VAV, velocity, average velocity is equal to 0. Why? Because displacement is equal to 0. VAV, that is average speed greater than 0. That is greater than 0, that is average distance, the distance change in distance greater than 0. In general, VAV, that is average velocity not equal to average speed, because that is delta F not equal to modulus of delta R vector. But sometimes that is average velocity is equal to that is average speed when the motion is uniform rectilinear motion. Okay, in uniform rectilinear motion, that is delta S is equal to modulus of delta R. Seventh point. Seventh point. V, that is average speed, not equal to negative. Okay, not equal to negative. That is VAV equal to 0 or VAV greater than 0. Greater than 0. VAV vector, that is average velocity. Average velocity less than 0, equal to 0 or greater than 0. Okay, greater than 0. Eighth point. If you draw a graph between time and displacement or distance, if you draw a graph between time and displacement or distance, okay, so this is time t, this is displacement, okay. Is T1, T2. So S1, is S2. Okay, S2. S2. So this is delta T, this is delta S, so this is the angle theta. Okay, theta. So if you draw a graph between time and displacement or distance, okay, distance. So from this graph, average velocity, okay, average velocity VAV is equal to, or average speed is equal to delta S by delta T. So that's equal to, so this line A, B, okay. So VAV is equal to delta S by delta T, that is equal to slope of the line AB. So that's equal to F tan theta. Okay, tan theta. So average velocity can be determined from this graph. That is equal to VAV is equal to delta S by delta T. That is equal to slope of the line AB. So that is equal to tan theta. Okay, tan theta. It is very important. So these are the points regarding, that is, average speed and average velocity. So the next is study on instantaneous velocity and speed. Okay, we are going to make a study on instantaneous velocity and speed. So, first point, instantaneous speed, V vector is equal to limit delta T tends to 0 delta r vector by delta t. So that's equal to dr vector by dt. So this is the instantaneous velocity. V vector is equal to limit delta t tends to 0 delta r vector by delta t, that's equal to dr vector by dt. So speed v is equal to modulus of velocity. Okay, modulus of velocity. That is v is equal to modulus of v vector. Okay, modulus of the magnitude of velocity is speed. Okay. Second point. Velocity vector. So unit meter per second. Speed, that is scalar, that is unit meter per second. Okay, meter per second. Third point. During uniform motion, VAV, that is average velocity is equal to instantaneous velocity, which is equal to constant. During uniform motion, average velocity is equal to instantaneous velocity is equal to constant. But the converse may not be true. Okay, suppose if VAV vector is equal to V vector, then the motion is not uniform. Then the motion may not be uniform. Then the motion may not be uniform. So during uniform motion, so the average velocity is equal to instantaneous velocity is equal to constant. But the converse may not be true. That is, if average velocity is equal to instantaneous velocity, then the motion may not be uniform. How we can say that? So from this graph, so this is time and this is displacement. Okay. So T0. So this is O, this is A. Slope of the line from this graph, slope of the line OA, that is average velocity in the time interval t0 is equal to slope of the slope of the line at A, slope of the line at A, that is instantaneous velocity. Okay, slope of the line OA, that is average velocity at this time interval t0, is equal to slope of the line at A, that is the instantaneous velocity at A. But when you observe the graph, you can understand that if the motion is not uniform. The motion is not uniform. So that's why I told, that is the average velocity is equal to the instantaneous velocity is equal to constant for during uniform motion. Okay, uniform motion. But the converse may not be true. That is VAV, that is average velocity is equal to instantaneous velocity. Then the motion may not be uniform. So from this graph we can explain. That is the line OA, the slope of the line OA, that is the average velocity, is equal to slope of the line at A. So that is the instantaneous velocity is same. But the motion is, from this graph you can understand the motion is not uniform. Okay, not uniform. So the next point, fourth point. If V is equal to constant, so speed is equal to modulus of V vector, that is also constant. So which is in the case of uniform rectilinear motion. In the case of uniform rectilinear motion. But the converse may not be true. Means if speed is equal to constant, then velocity may not be constant. So in the case of uniform circular motion, uniform circular motion. Okay, an object is rotating, making a circular motion, that is the speed is constant. Okay, in each and every point the speed is constant, but the velocity is different due to the change in direction. So in this point, so the velocity is like this. Okay. So in the case of uniform circular motion, so speed is equal to constant. In each and every point the speed is constant, but the velocity is different because due to the change in direction. ठीक है, direction. Sixth point. velocity is equal to 0, positive or negative. Okay, velocity is equal to 0, positive or negative. But the speed never be negative. Okay, but the speed never be negative, because yes, speed is equal to modulus of v. So when you take the modulus, it is always positive. So here the velocity is negative, but if you take the modulus, it is always positive. So the velocity never be, speed never be negative. Okay. Seventh point. So the next point. If you draw a graph for time and displacement, so the point. If you draw a graph for speed and or displacement and time, okay, displacement and time. So this is time. So this is this. So the instantaneous velocity at the time t0, the instantaneous velocity at the time t0. So how will you find out t0? That is, instantaneous velocity is equal to ds by dt, that is equal to slope of the tangent, that's equal to tan theta. Okay, slope of the tangent. So at that point, what is the slope of the tangent? Okay. So here, so at this point, what is the slope of the curve? That means what is the slope of the tangent? The slope of the tangent gives the instantaneous velocity at that point. Okay. Then the last point. Eighth point. If the displacement is given in terms of t, okay, if displacement is given, it's a function of t, so s is equal to some a0 minus a1t minus a2 t square, So what is the velocity? Yes, velocity is equal to ds by dt. Okay, ds by dt. So that's equal to constant in differentiation 0 minus a1 plus 2 a2 t. Okay, 2a2 t. At time t is equal to 0. At time t is equal to 0, velocity v is equal to minus a1. Okay, minus a1. But the speed is equal to mod v, so that's equal to a1. Okay, that is v. Okay, so the velocity is negative, but the speed is positive. Okay, so these are the points regarding the instantaneous velocity and instantaneous speed. So the last concept. If the body moves with velocity v1, v2, v3, etc., and covers the distance L1, L2, L3, etc. So what is the average velocity? So VAV is equal to, so what is the formula? That is delta S by delta T. Okay. So delta is equal to L1 plus L2 plus L3 plus etc. So that's equal to summation of Li. So delta T is equal to, here time is not given, so V is equal to d by T. Okay, so T is equal to d by V. Okay, T is equal to L1 by V1 plus L2 by V2 plus L3 by V3 plus etc. So that's equal to summation Li by Va. Okay. So therefore VAV is equal to, so delta S, that is summation of Li divided by summation of Li by Va. So this is the average velocity. Okay, average velocity. So note, if the distance traveled by the body L1 is equal to L2 is equal to L. L1 is equal to L2 is equal to L. So summation of Li is equal to L1 plus L2. So L1, so Li is equal to L plus L. So that's equal to 2L. So summation of Li by Va. So that's equal to L by V1 plus L by V2. Okay. So therefore, the average velocity VAV is equal to 2L divided by, so take L commonly outside, that is L into 1 by V1 plus 1 by V2. So L get cancelled. So that's equal to 2 divided by, take LCM, that is V1, V2 divided by V1 plus V2. So that's equal to 2 into V1, V2 divided by V1 plus V2. That is VAV. Suppose the body moves with the distance, equal distances, okay, with the different velocity, equal distances with the different velocity. So the average velocity is equal to VAV is equal to, so 2 V1 V2 divided by V1 plus V2. So this formula we will use for doing solving the numericals. We will use this formula. Okay. Suppose if the body moves with velocity v1, v2, v3, etc. in the time intervals t1, t2, t3, etc. Okay, etc. So what is the average velocity? So v AB is equal to, so delta S by delta T. Okay. So delta S is equal to, so here the distance is not given. So V is equal to d by t. So distance is equal to V into t. So V1 t1 plus V2 t2 plus V3 t3 plus etc. So that's equal to summation Vi Ti. Delta T is equal to T1 plus T2 plus T3 plus etc. summation of, that is Ti. Okay, therefore V AB is equal to sigma summation of Vi Ti divided by summation of Ti. So this is the formula. Note, if T1 is equal to T2 is equal to T. Okay, T1 is equal to T2 is equal to T. So summation of Vi Ti is equal to V1 T plus V2 T. Okay, so T take commonly outside, V1 plus V2. Okay, then summation of Ti is equal to T plus T, that's equal to 2T. Okay, so V AB is equal to, so T into V1 plus V2 divided by 2T. So TT get cancelled. So VAB is equal to V1 plus V2 divided by 2. So this is the average velocity in the case of a body moving with a different velocity in the same interval. Okay, same interval. So different velocity in the same interval. This formula is also very important. So we will use this formula for solving the numericals. The first problem, a car is moving along x-axis as shown in the figure. It moves from O to P in 18 seconds and returns from P to Q in 6 seconds. What are the average velocity and average speed of the car in going from 1. From O to P, 2. From O to P and back to Q. Okay, so this is given in the question, that is problem 1. Okay, P1. This is given in the question. So a car is moving in the x-axis. So the x-axis given with the time and the corresponding distance is given in the x-axis. So the lower part shows the time values and the upper part shows the corresponding distance values. Okay. So we have to find the average velocity and average speed. So case 1, from O to P. So consider this point as, that is O. Okay. This is P and this is Q. Okay. Right? So find the average velocity and average speed. Case 1 from O to P. So the car starts the journey from O and reaches the point P. So we have to find average velocity and average speed. In the second case, from O to P and back to Q. So from P the car goes to the point Q. So in that case also we have to find the average velocity and average speed. Okay. So first case, case 1. So from O to P. Okay, O to P. Average speed, okay, is equal to average speed. What is the formula? That is distance divided by time. Okay, distance covered by time taken. Okay, so this is equal to from O to P. This is the point O, this is the point P. So how much distance it covered? That is from 0 meter to 360. So the distance covered is 360 by time taken. That is from the diagram it is clear, that is 18 seconds. 18 seconds. Clear? So cut it. So 18, that is 2 times. Okay. So 20. So that's equal to 20 meter per second. 20 meter per second. Okay. So next, average velocity. Average velocity is equal to. So average velocity is equal to displacement by time taken. Okay, displacement by time taken. So here, so what is the displacement? It is in the 0 to this point, that is O to this point P. So what is the displacement? That's equal to, so velocity displacement we are considering in this direction, rightward direction. So we will take that is plus, okay, plus 360 by time taken, that is 18. So 18 cut, that is 220. So that's equal to plus 20 meter per second. So average velocity is equal to displacement by time taken. So displacement will, that is either positive or negative, that is direction. So when we say the displacement, we have to say the direction also. So the positive direction, okay, positive direction. So plus 360 by time taken. So velocity also, that is a vector quantity. So positive or negative. So plus 20 meter per second. Clear? Average speed and the average velocity. Then case 2, from O to P back to Q. The car starts the journey from this point O and it reaches the point P and again it goes back to the point Q. Okay. So average, first we have calculated, that is average speed. Average speed is equal to distance covered by time taken. Okay, that's equal to distance covered. So from O to P, that is OP, plus, so from P to Q, that is PQ divided by time taken, that is from O to P, how much time, that is 18, plus from this P to Q, how much, that is 6. Okay, so OP, so that is 360 plus PQ 40, 80, 120, so 120 divided by 18 plus 6, that is 24. Okay, 360 460 480. Okay, so 480 by 24. Okay, so cut it, 24, that is 48, that is 2 times and 20, so that's equal to 20 meter per second. That is the average speed. Okay, average speed. Next is average velocity. Average velocity is equal to displacement by time taken. Displacement by time taken. So displacement, in this case, the first point, that is the car starts the journey from O to P and it goes back to the point Q. So what is the displacement? So displacement is the shortest distance between the starting point and the ending point. So end point. So the car is at the initial point is O and the final point is Q. So that is the distance. So that is the displacement. So 240 divided by time taken. So 18 plus 6, that is 24. Okay, 24. So that's equal to cut, that is 1, 10. So that is equal to 10 meter per second. So this plus, so this plus 10 meter per second. That is the average velocity. Okay, clear? Okay. P2. An object starts from A and travels to the point B. An object starts from A and travels to the point B with velocity, that is 40 meter per second. Okay, 40 meter per second. And returns back to the point A with the velocity, that is 60 meter per second. Okay, 60 meter per second. An object starts from A and travels to the point B. Okay, with the velocity 40 meter per second and returns back to the point A with the velocity 60 meter per second. What is the average velocity? Average velocity. What is the average speed? Average speed. First, average speed. Average speed. What is the formula? Distance covered. Distance covered by time taken. Distance covered by time taken. So that's equal to distance covered from A to B. I am considering this distance as S. Okay, yes. So from A to B it travels and again it goes back to the point B. So the total distance covered is 2s. Okay. Time taken. Time it is not given. Time not given. So velocity is equal to displacement by time. So time is equal to displacement by velocity. Okay, displacement by velocity. So 2s divided by, so time we can write in terms of that is displacement and velocity. So for the forward journey, so what is the displacement? So that is s by velocity, that is 40 plus. Okay, for the backward journey, what is the distance? That is s divided by, what is the velocity? That is 60. Right? So this s and this s will cut. Okay, that's equal to 2 into, so 40 into 60 divided by 40 plus 60. Okay, so that's equal to 2 into 40 into 60 divided by 100. Okay, 0, 0 cut, 0, 0 cut. 6 4s are 24. 24 into 2, that is 48. So that's equal to 48 meter per second. That is the average speed. Average speed. Clear? So otherwise we can solve this problem in another way. So when I take the concept, so in the last session I derived on formula. Okay, derived on formula. Which formula? So if an object travels equal distances with a different velocity. Okay, if an object travels equal distances with a different velocity, what is the average speed? I have derived on formula. That is average speed is equal to 2 v1 v2 divided by v1 plus v2. The body travels equal distances with a different velocity. Average speed is equal to 2 v1 v2 v1 plus v2. So that's equal to 2 into v1, that is 40 plus 40 into, what is the second velocity? That is 60. v1 plus v2, that is 100. Cut. That is 6 4s are 24. 24 into 2, that is 48 meter per second. So in this way also you can solve this problem. Clear? Okay. What is average velocity? Average velocity is equal to 0. Why? That is, average velocity is equal to displacement by time taken. So in this case, what is the displacement? Body starts from A, and that is in the last point, that is final point is also A. So the body starts from A and reaches the point again. Yes. So what is the displacement? Displacement is equal to 0. So average velocity is equal to 0. Clear? Okay. So the third problem. Okay, third problem. A body traveling along a straight line traversed one half of the total distance with a velocity v0. The remaining part of the distance was covered with a velocity v1 for half the time and with velocity v2 for other half of time. Find the mean velocity averaged over the whole time of motion. So it is given in the question. Okay. So P3. Okay. An object is moving in a straight line. Straight line. Okay. Straight line. So we consider the distance, that is as x. Okay, x. What is given? So half of the distance, that is x by 2, is moving with the velocity that is v0. So it takes the time that is t1. Okay, t1. So the remaining half of the distance, that is x by 2. So x by 2 is covered with the time t2. T2. Okay. So in that t2, the half of the time t2 is covered with the velocity. Okay. So t2 is covered, t2 by 2 is covered with the velocity v1, and the remaining half of the time, that is t2 by 2, is covered with the velocity v2. Okay. So the remaining half of the distance x by 2 is covered with the time t2. In that time t2, the half of the time t2 by 2 is covered with the velocity v1, and the next half of the time, that is t2 by 2, is covered with the velocity v2. So we have to find the average velocity. So clear? Question clear? So straight line, my body is making a straight line motion. So we consider the distance. So all distance covered by the body is x. Okay, x. So the question, in the question it is given. So the half of the distance, that is x by 2. Okay, x by 2 is covered with the velocity v0. So with the time t1. So the remaining half of the distance x by 2 is covered with the time t2. In that time, so the half of the time, that is t2 by 2, is covered with the velocity v1, and the other half of the time t2 by 2 is covered with the velocity v2. So we have to find the average velocity. Clear? So average velocity is equal to displacement by time. Okay, displacement by time. Okay, so the total distance covered is, that is x. Okay, so that's equal to x divided by. So the time taken for the whole journey, that is t1 plus t2. Okay, t1 plus t2. Okay. So here, from this, t1 is equal to, so velocity is equal to displacement by time. Time is equal to displacement by velocity. So t1 is equal to, so distance, okay, that is x by 2 divided by v0. So x by 2 v0. So this is the time t1. t1 is equal to x by 2 v0. So in this part, okay, so the distance x by 2 is equal to, velocity is equal to displacement by time. So displacement is equal to velocity into time. Velocity into time. So x by 2 is equal to velocity, so v1, okay, into time. Which time? That is t2 by 2 plus next velocity, that is v2 into t2 by 2. Okay. So x by 2 is equal to, take t2 by 2 commonly outside, t2 by 2 v1 plus v2. Okay. So these two cancel. So time t2 is equal to x divided by v1 plus v2. Okay, v1 plus v2. So we get t1, t2. Okay, so the total distance x. Next, to find the average velocity, t1 plus t2. So we will get t1, t2. So we have to find t1 plus t2. Okay, that is t1 plus t2 is equal to x by 2v0 plus t2 x by v1 plus v2. So that's equal to 2v0 into v1 plus v2 x into v1 plus v2 plus x into plus x into 2 v0. Okay, v0. So that's equal to, take x commonly outside, v1 plus v2 plus 2v0 divided by 2v0 into v1 plus v2. Okay, so that is t1 plus t2. Substitute. So that's equal to x divided by t1 plus t2. So x into v1 plus v2 plus 2v0 divided by 2v0 into v1 plus v2. Okay, v2. So x cut. So that's equal to, I'm writing here. So 2v0 into v1 plus v2 divided by v1 plus v2 plus 2v0. So this is the average velocity. So 2v0, v1 plus v2, choose v0 into v1 plus v2 divided by v1 plus v2 plus 2v0. Clear? So the next sum. Before. A table clock has its minute hand. A table clock has its minute hand. Length 4 centimeter. Okay, length 4 centimeter. Length equal to 4 centimeter. What is the average velocity of the tip of the minute hand? Tip of the minute hand. 1. Between 6 a.m. and 6:30 a.m. Okay, 6:30 a.m. 2. Between 6 a.m. and 6:30 p.m. 6:30 p.m. Clear? Table clock has the minute hand of length 4 centimeter. So what is the average velocity of the tip of the minute hand between 6 a.m. and 6:30 a.m. and the second one 6 a.m. and 6:30 p.m. Okay. So average velocity is equal to, what is the formula? Average velocity is equal to displacement by time. Displacement by time. Okay. So when the time is 6 a.m., the minute hand is at 12. So this is suppose 12. This is 3, This is 6. This is 9. Okay, the minute hand is at 12. So the time is 6:30 a.m. means the minute hand come here. Okay. So the displacement, so starting position to end position. So this is the displacement. Okay. Displacement. So displacement is equal to, that is, this is 4 and this much 4. So 4 plus 4, that is 8. 8 divided by time taken. So 6 a.m. to 6:30 a.m. means what is the time taken to reach from here to here? That is 30 minutes. 30 minutes. Okay. So 30 into, so we have to convert it into seconds. So 30 into 60. So that's equal to 18,800. 1,800. Okay. So 8 divided by 1,080. Clear? So that's equal to 8 divided by 18 into 10 to the power minus 2. 10 to the power minus 2. So that's equal to 0.44 into 10 to the power minus 2. 8 divided by 18. So 0.44 into 10 to the power minus 2. That's equal to 4.4 into 10 to the power minus 3. Minus 3. What is the unit? So this is centimeter. Centimeter, this is second. So that's equal to unit is centimeter per second. Okay, that is the first case. Clear? Then it's the second case. Second case. Between 6 a.m. and 6:30 p.m. 6:30 p.m. So 6 a.m. and 6:30 p.m. also. So 6 a.m. Okay. 6 a.m., 7 a.m., 8 a.m., 9 a.m. So the time is going on. So evening it will reach the 6 o'clock. That is 6 p.m. Okay, 6 p.m. In that position also the minute hand is in this position, and 6:30 p.m. also it will come to this position. Okay, 6 a.m. means this is the position of the minute hand. Okay, when it reaches 6:30 p.m., so the position of the minute hand is in this position. So the displacement starting point is this one, and the end point, that is 6:30 p.m. This is the position of the minute hand. So what is the displacement? Starting point to end point, the distance between the start point to the end point. So displacement is equal to again 8. Okay, 8 divided by time. How much time to reach 6:30 p.m. 6 a.m. to 6:30 p.m. Morning 6 a.m. to evening 6 p.m. So how much hours? That is 12 hours. Okay, 12 hours. Plus 6:30 p.m. So 12.5. 12 hours and 30 minutes. 12 hours and 30 minutes. So that is 12.5. So 12.5 into 60. That is hours into minutes. Into again 60. That is seconds. Okay, seconds. So that's equal to, we will get, that is 45,000. Okay, if you multiply and to verify the answer, that is 45,000. Okay, so that's equal to 45,000. Okay, 45,000. So that's equal to 8 divided by 45 into 10 to the power minus 3. Okay, 10 to the power minus 3. Clear? That's equal to 0.18 into 10 to the power minus 3. So 1.8 into 10 to the power minus 4 centimeter per second. Centimeter per second. That is answer. Clear? Okay. So the next question. So P5. Find the correct statement from the following. Find the correct statement from the following. So we can see one by one. So the first statement, the magnitude of the velocity of a particle is equal to its speed. So here the velocity means instantaneous velocity and the speed is the instantaneous speed. So while we were discussing the concepts, that is we discussed, that is instantaneous speed. Okay, instantaneous speed is equal to, so the magnitude of velocity. So this point is correct. Okay, this statement is correct. The second point, the magnitude of average velocity in an interval is equal to its average speed in that interval. Okay, so what is average velocity? Average velocity VAV vector is equal to displacement by time. So what is average speed? VAV is equal to distance by time. Okay, so we can neglect this time because in that interval, particular time interval, so time is same. So displacement is equal to distance. Whether our question is whether the displacement is equal to distance. It is displacement is not always equal to distance. So we studied that is displacement less than or equal to distance. Okay, displacement less than or equal to distance. We can't say that displacement is always equal to distance. Displacement may be equal to distance or less than or equal to distance. So the magnitude of average velocity in an interval is equal to its average speed in that interval. So it's not true. Okay, not true. Then the third one, it is possible to have a situation in which the speed of a particle is always zero. Speed of a particle is always zero in the sense the object is at rest. Okay, the object is at rest. It is possible to have a situation in which the speed of a particle is always zero. Zero means the speed of a particle is always zero means the object is at rest. But the average speed is not zero. Average speed is equal to distance by time. An object is at rest. How is it possible that is an object is at rest can travel a certain distance? It is not possible. Okay, so that's why this statement is wrong. Okay, this statement is wrong. Clear? So it is possible to have a situation in which the speed of a particle is always zero. Means the object is at rest. Okay. So, but the average speed is not zero. Average speed is equal to distance by time. So, how is it possible the object which is at rest can travel a distance? It's not possible. So, VAV is equal to distance by time. Okay, it's not possible. That's why that statement is also wrong. Then, fourth point. It is possible to have a situation in which the speed of the particle is never zero. Speed of the particle is never zero. That means the object is traveling with velocity. Okay, some velocity. It is not possible. It is possible to have a situation in which the speed of the particle is never zero. That means the object is moving with a certain velocity. But the average speed in that interval is zero. That is, average speed VAV is equal to distance by time. It has an average velocity. An object is moving with a certain velocity means it must have average velocity. But here it is telling that the average speed in that interval is zero. So that's why this statement is also wrong. Okay. So the first statement only is correct. Okay. So the sixth problem. Sixth and the last problem, okay, in this session. Okay, P6. There is one escalator. Okay, escalator of length L is equal to 10 meter. Escalator 10 is L is equal to 10 meter. So the escalator is moving with the velocity that is VE. Okay. There is one boy who is going through this escalator. Okay, escalator. So suppose VB is the velocity of the boy. Okay. So number one, when the escalator is at rest, T1 is equal to 6 minutes. That is, when the escalator is at rest, the time taken by the boy to reach the top, that is equal to 6 minutes. 2. When the escalator is moving, T2 is equal to 2 minutes. So, okay, the boy is walking through the escalator and also the escalator is also moving. So, the time taken by the escalator to reach, time taken by the boy to reach the top is 2 minutes. Third one, find the time when the boy is at rest. Find the time when the boy is at rest in the moving escalator. Okay. So we have to find the time of the boy to reach its top in the moving escalator when he is at rest. Okay, rest. Clear? So when the escalator, first case 1. When the escalator is at rest, T1 is equal to 6 minutes. So T1 is equal to, so length of the escalator L divided by, that is VB, velocity of the boy. Okay. So T1 taken by the time T1 is equal to 6 minutes. 6 minutes. So when we convert it into second, that is 6 into 60. That is 360 is equal to L. So the length of the escalator by VB. So that implies VB is equal to 10 divided by 360. This cut. So VB is equal to 1 by 36. Velocity of the boy is equal to 1 by 36. Okay. Then case 2. When the escalator is moving, T2 is equal to 2 minutes. So escalator is moving, also the boy is moving. Okay. So T2 is equal to L by VB plus VE. Okay. T2, that is 2 minutes. 2 into 60, that is 120, is equal to 10 divided by VB plus VE. Okay, VB plus VE. VB plus VE is equal to 10 divided by 120. Okay. So, okay. That is VB plus VE is equal to 1 by 12. So from this, V is equal to 1 by 12 minus, what is the value of V? 1 by 36. Okay, 1 by 36. So LCM 36, 3 minus 1. So 2 by 36, that's equal to 1 by 18. So V is equal to 1 by 18. Okay, 1 by 18. So third case, case 3. Find the time when the boy is at rest in the moving escalator. Okay, escalator. So T3 is equal to T3 is equal to that is L by V. Okay, escalator is moving. When the boy is at rest, okay, T3 is equal to L by V. That's equal to 10 divided by 1 by 18. That's equal to 10 into 18. That's equal to 180 seconds or 3 minutes. Okay, 3 minutes. That is the answer. Clear? Okay. Instantaneous velocity V vector is equal to limit delta t tends to 0, delta x by delta t, that's equal to dx by dt. So we derived the formula like this. Okay. So instantaneous velocity is equal to limit delta t tends to 0, delta x by delta t, that's equal to dx by dt. So in this topic, the first type of problem is the displacement will be given. Okay, displacement in terms of time. So displacement is a function in terms of time will be given. So you will be asked to find the instantaneous velocity. So it's nothing but the displacement x is given. Okay, x will be given. So you will be asked to find the instantaneous velocity. The so formula is nothing, that is v vector is equal to dx by dt. So this is the formula to find the instantaneous velocity. So in this type of problems, that is the problems related to instantaneous velocity, means integration and differentiation should be very clear. Okay, so both differentiation and integration, using integration and differentiation only we will solve all the problems. So if you are not clear in differentiation and integration, in physics 2020 there is a playlist that is mathematical support for physics. So go to that playlist and watch the video of differentiation and integration for getting the basics of differentiation and integration. Okay. Okay. Next we will solve the problems. That is first problem. The displacement of an object moving in a straight line is given by x is equal to 2t square plus t plus 5. Okay, plus 5. Where x is expressed in meters and t is expressed in minutes. So what is the velocity? What is the velocity at t is equal to 2 seconds? Okay, t is equal to 2 seconds. So here the displacement is given in terms of time. So the object moving in a straight line, x is equal to 2t square plus t plus 5. Okay, so we have to find the velocity at t is equal to 2 seconds. So the given x is equal to 2t square plus t plus 5. Okay, so velocity v is equal to formula, that is dx by dt. Okay, dx by dt. So that's equal to d by dt of x, that is 2t square plus t plus 5. So that's equal to So differentiation of 2t square, that is 4t. Okay, 4t. Plus differentiation of t, that is 1. Plus differentiation of constant, that is 0. Okay, so v is equal to 4t plus 1. So we have to find the velocity at t is equal to 2 seconds. So t is equal to 2 seconds. So v is equal to 4 into 2 plus 1. So 4 into 2, that is 8. 8 plus 1, that is 9 meter per second. 9 meter per second. That is the answer. So here, so the displacement is given. So t2 t square plus t plus 5 in terms of time. So we have to find it is asked to find the velocity at t is equal to 2 seconds. So v is equal to formula dx by dt. So d by dt of 2t square plus t plus 5. So we are differentiating. So the differentiation of 2t square, that is 4t, plus differentiation of t 1, differentiation of constant, that is 0. So v is equal to 4t plus 1. So it is asked to find the velocity at t is equal to 2 seconds. So t is equal to 2 seconds. So v is equal to 4 into 2 plus 1, that is 8 plus 1, that is equal to 9 meter per second. So second problem. The displacement x of a particle moving in one dimension under the action of a constant force is related to the time t is given by the equation t is equal to root x plus 3, where x is in meters and t is in seconds. Find the displacement of the particle when its velocity is 0. So the second question. So from the question it is given that is t is equal to root x plus 3. Okay, the displacement and the time relation is given by t is equal to root x plus 3. So we have to find the displacement when velocity is equal to 0. Velocity is equal to 0. So the given t is equal to root x plus 3. Okay. So x is the displacement. X is the displacement. So root x equal to t minus 3. Okay, squaring on both sides. X equal to t minus 3 whole square. So that's equal to t square plus 9 minus 60. So this is the displacement. This is the displacement, which is the displacement is a function of time. Okay. So we have to find the displacement when velocity is equal to 0. So when next we have to find the velocity. So v is equal to dx by dt. Okay, v is equal to dx by dt. So that's equal to t square, differentiation of that is d by dt of t square plus 9 minus 60. Okay, that's equal to t square, that is 2t plus 0 minus 6. Okay, 6. So velocity is equal to 2t minus 6. 2t minus 6. So when velocity is equal to 0, that is when v is equal to 0, that is 2t minus 6 equal to 0. 2t is equal to 6. So t is equal to 6 by 2, that's equal to 3. Okay, then. So when time t is equal to 3 seconds, the velocity becomes 0. So what it is asked in the question, that is we have to find the displacement when v is equal to 0. When v is equal to 0 means that is the time t is equal to 3 seconds, the velocity becomes 0. So at that time we have to find the displacement. Okay, so the displacement x is equal to t square plus 9 minus 60. So at t is equal to 3 seconds. Okay, so x equal to t square, that is 9 plus 9 minus 6 into 3, that is 18. So 18 minus 18, that's equal to 0. So the displacement is equal to 0. Clear? So the given equation is t is equal to root x plus 3. So we have to find the displacement when velocity is equal to 0. So t is equal to root x plus 3. So we are finding the displacement from this equation by rearranging the variables. So x is equal to t minus 3 the whole square. So x is equal to t square plus 9 minus 60. So we have to find the velocity. So v is equal to dx by dt. So the first derivative of displacement. So t square plus 9 minus 60. So we are getting that is velocity is equal to 2t minus 6. When velocity is equal to 0, that is 2t minus 6 equal to 0, we find the value of time. So t is equal to 3 seconds. So at the time t is equal to 3 seconds, the velocity becomes 0. At that particular time, what is the displacement? So x is equal to t square plus 9 minus 60. So x is equal to, we are substituting the value of time. So we get x is equal to 0. The next type of problems in instantaneous velocity. So the first type problems, displacement is given. We have to find the instantaneous velocity. So v is equal to dx by dt. So in the second type problems, instantaneous velocity will be given. So you have to find the displacement. Okay, displacement. So the instantaneous velocity, so in this we will integrate the equation. Okay, so the first one, differentiation. The instantaneous velocity is given, suppose if you want to find the displacement means you have to integrate. Okay, so the instantaneous velocity will be given in one of these three forms, that is v is equal to some constant. Instantaneous velocity will be given as v is equal to constant, or v is equal to f of x, that is depends on displacement. Displacement. 3, v is equal to f of t, that is depends on time. Depends on time. Okay, so the instantaneous velocity will be given in one of these three forms. So the following steps are to be followed to find the displacement. Step 1. Write v is equal to dx by dt. Right, v is equal to dx by dt. Step 2. Separate the variables. Separate the variables in the sense, suppose the differential equation contains the x variables and the t variables. So separate all the x variables in one side and separate all the t variables in another side. That is, separate the variables. Step 3. Integrate the differential equation. Okay. Integrate the differential equation. You will get the required data. Okay, required data. So understand. So the instantaneous velocity is given. You have to find the displacement. So the in this we are using integration. So instantaneous velocity will be given in one of these three forms. Instantaneous velocity may be given as a constant. Instantaneous velocity v is equal to f of x. That is, otherwise v is equal to f of t. Okay. Following these three steps to find the answer. First step, that is write v is equal to dx by dt. Step 2, separate the variables. Okay. Step 3, integrate the differential equation. So in the first case, v is equal to k. So that is displacement we will get, that is x is equal to vt. Okay, x is equal to vt. Second case. So v is equal to f of x. Okay, v is equal to f of x. First step, that is write v is equal to dx by dt. Okay, dx by dt is equal to f of x. Okay, separate all the x variables in one side and t variables in another side. So dx by f of x equal to dt. Okay, third step is integrate. Right, integrate. Okay, the time varies from t1 to t2, so that the displacement varies from x1 to x2. Okay, so this will give the displacement. Okay. Then third case. So v is equal to f of t. So v is equal to f of t. The first step, write v is equal to dx by dt. So that's equal to f of t. So arrange, separate all the t variables in one side and x variables in one side. So dx equal to f of t dt. So the next step is integrate. Okay, integrate. So dx is equal to integral of f of t dt. So the t varies from t1 to t2, so that the displacement varies from x1 to x2. So this will give the answer. Okay. So problem number 3. In a particle's motion, its instantaneous velocity is given by v is equal to 2t plus 5. Okay, v is equal to 2t plus 5. Find the displacement. In the interval t is equal to 0 and t is equal to 2 seconds. Okay, t is equal to 0 and t is equal to 2 seconds. So listen here. So the instantaneous velocity is given. V is equal to 2t plus 5. We have to find the displacement in the interval t is equal to 0 and t is equal to 2 seconds. So first given equation, v is equal to 2t plus 5. V is equal to 2t plus 5. First step 1, that is right. V is equal to dx by dt. So that is the step. T is equal to 2t plus 5. So arrange all the here, that is 2t plus, this is a constant. Okay. So arrange the t variables in one side and x variables in another side. So dx equal to 2t plus 5 into dt. Okay, then next step, integrate. So integral of dx equal to 2t plus 5 into dt. So integration. So we have to find the displacement at the time, that is 0 is equal to t is equal to 0 and t is equal to 2 seconds. So the lower limit is 0. Time varies from 0 to 2. So that the x varies from x1 to x2. Okay, x2. So integration of dx, that is x. Okay, x. So x1 to x2, that's equal to integration of 2t, that is 2t square by 2. Okay, so that is t square plus 5 dt, that is 5t. So the limit is 0 to 2. So here x2 minus x1 is equal to, apply the limit, upper limit, that is t square, that is 4 plus 5 into 2, that is 10 minus 0. So lower limit 0. So x2 minus x1, that is the displacement. So displacement is equal to 10 plus 14, that is 10 plus 4, that is 14 meter. 14 meter. That is the answer. Okay. So the next question. A particle located at x equal to 0 at a time t is equal to 0 starts moving along the positive x direction with a velocity v that varies as v is equal to alpha root x. The displacement of the particle with the time mass. So, fourth problem. So it is given that in the question, when x is equal to 0, when time is equal to 0, that's one condition is given. So the velocity, instantaneous velocity of the particle is given, v is equal to alpha into root x. So we have to find the displacement of the particle with the time. So we have to find the relation between displacement and time. Okay, displacement and time. Okay. So first equation, that is v is equal to alpha root x. Alpha root x. Alpha root x. Right. So first step, right, v is equal to dx by dt. So dx by dt is equal to alpha root x. Second step, arrange the variables. Okay, so dx by root x equal to alpha dt. Okay, alpha dt. So x power minus 1 by 2 dx equal to alpha dt. Okay, alpha dt. Then next step, integrate. Okay, so we are integrating without limit. Okay, without limit. That is indefinite integration. Indefinite integration. So integral of x power minus 1 by 2 dx equal to integral of alpha dt. Alpha dt. So x power minus 1 by 2. So that is equal to 2x 1 by 2. Okay. Minus 1 by 2 plus 1, that is 1 by 2 divided by 1 by 2, that is 2. 2x power 1 by 2. So that's equal to alpha integration of dt, that is t, plus constant of integration. So we are integrating without limits. So constant of integration. So one initial condition is given, that is when x is equal to 0, time is equal to 0. So apply that condition here, that is x equal to 0. So x equal to 0 means that is 0 is equal to alpha into time is equal to 0. That is 0 plus c. So the constant of integration, the value of constant of integration is c is equal to 0. So we will get 2x power 1 by 2, that's equal to alpha t. Okay, alpha t. So x power 1 by 2 is equal to alpha t by 2. X is equal to alpha square t square by 4. Okay. So here alpha is a constant. So alpha square is constant. 4 is constant. Okay. So x is equal to some constant into t square. From that we can write that is x is directly proportional to t square. X is directly proportional to t square. Okay. So the displacement, the relation between displacement and time is, that is, displacement is proportional to the square of the distance. That is the relation. X is directly proportional to t square. So x is equal to alpha square by 4. That is a constant into t square. So we can write x is directly proportional to t square. So that is the answer. So the next problem. A car is moving with a velocity v is equal to alpha root x. Okay, v is equal to alpha root x. Starting from x equal to 0 when t is equal to 0. Okay, t is equal to 0. Find the average velocity. Find the average velocity when t1 is equal to 2 seconds and t2 is equal to 5 seconds. Okay. So listen here. What is given? A car is moving with the instantaneous velocity v is equal to alpha root x. Starting from x equal to 0 when t is equal to 0. One condition is given. Initial condition is given. Okay. We have to find the average velocity of the car when t1 is equal to 2 seconds and t2 is equal to 5 seconds. Okay. So first v is equal to alpha root x. Alpha root x. First step, that is dx by dt is equal to alpha root x. Arrange the variables. Dx by root x, okay, is equal to alpha t. Alpha t. So x power minus 1 by 2 into dx equal to alpha t. Integrate. Okay, integrate. X power minus 1 by 2 dx equal to integral of alpha t. Okay, alpha t. So x power 1 by 2, that is 2 x power 1 by 2 is equal to alpha here, sorry, alpha dt. Alpha dt. Alpha dt. Okay, alpha t plus constant of integration. Okay, constant of integration. So 2x power, when one initial condition is given from x equal to, when x equal to 0, t is equal to 0. So substitute here x equal to 0. So this term totally 0. T is equal to 0, this is equal to 0. So c is equal to 0. Constant of integration we will get c is equal to 0. So 2x power 1 by 2 is equal to alpha t. Alpha t. Okay. So x power 1 by 2 is equal to alpha t by 2. So x equal to alpha square t square by 4. X equal to alpha square t square by 4. So what is average velocity? average velocity, that is VAV, is equal to x2 minus x1 divided by t2 minus t1. Okay, t2 minus t1. When t1 is equal to 2 seconds. T1 is equal to 2 seconds. So we get x1 is equal to alpha square t value, that is 2, that is 4 divided by 4. 4 get cancelled. So x1 is equal to alpha square. Okay. So x equal to, next case, so time t2 is equal to 5 seconds. Okay, t2 is equal to 5 seconds. So x2 is equal to alpha square t square, that is 5 square, that is 25 by 4. 25 by 4. Okay. So x2 is equal to 25 alpha square by 4. 25 alpha square by 4. So x2 minus x1 equal to x2 minus x1 is equal to x2 25 alpha square by 4 minus, what is x1, that is alpha square. So that's equal to 25 alpha square minus 4 alpha square by 4. So that is 21 alpha square by 4. So average velocity V AV vector, that is average velocity, is equal to x2 minus x1. x2 minus x1, that is 21 alpha square by 4. Okay, divided by t2 minus t1, that is 5 minus 2, that is 3. Okay, so 21 alpha square by 4 3s are 12. So that is the V average velocity. The average velocity. Clear? So the next question, the position x of a particle with respect to time t along x-axis is given by x is equal to 9t square minus t cube, where x is in meters and t in seconds. What will be the position of this particle when it achieves maximum velocity along the positive x direction? So, sum the question. So this is given in the question. So the position of the object is given by the equation x is equal to 9t square minus t cube. So we have to find the position of the same object when it reaches the maximum velocity. When it reaches the maximum velocity. So x equal to 9t square minus t cube. Okay, t cube. So here we will use the concept of maxima and minima of a function. Maxima and minima of a function. So if you don't have the idea of maxima and minima of a function, if you go to the Physics 2020 and the mathematical support for physics, that is in that video, that is differentiation. So differentiation, one of the video in the last topic I have discussed, that is maxima and minima of a function. Okay. So here x equal to 9t square minus t cube. So maximum velocity, first we have to find the velocity, that is v is equal to dx by dt. V is equal to dx by dt. So that's equal to 18 t minus 3 t square. Okay, t square. So the maximum velocity means dv by dt is equal to 0. Maximum velocity means dv by dt is equal to 0. So we have to find this if v is equal to 18t minus 3t square. So dv by dt. So dv by dt is equal to 18 minus 60. 60. So to find the maximum or minimum of this function, that is velocity function, dv by dt is equal to 0. That is 18 minus 60 is equal to 0. Okay. So 60 is equal to 18. So t is equal to 18 by 6. Okay. T is equal to 3. T is equal to 3. So when time t is equal to 3 seconds, the function may be maximum or minimum. Okay, maybe maximum or minimum. Because when you draw the graph, that is time and velocity. So during this, that is minimum and maximum. Okay, minimum and maximum, that is dv by dt is equal to 0. So t is equal to 3 means the function may be maximum or minimum. Okay, may be maximum or minimum. So we have to confirm whether it is maximum or minimum. We have to go to the second derivative check. Okay, second derivative check, that is dv by dt. So d square v by dt square. So that is equal to, so 18, that is 0 minus 0. Okay, 0 dv by dt is equal to 18 minus 60. Okay, d square v by dt square is equal to, constant difference is 0 minus 6 into 1, that is 6. Okay, so d square v by dt square is equal to minus 6. So when t is equal to 3, when t is equal to when t is equal to 3, so d square v by dt square is equal to minus 6, that is negative. If the second derivative is negative, then definitely in that value the function is maximum. If the d square by dt square, the second derivative is positive, means that is at that value, that is the function is minimum. So here we are getting that is minus value, so definitely the function is maximum. Okay, function is maximum. So the velocity is maximum. So at that value of time t is equal to 3, so the velocity is maximum. It reaches the maximum velocity. So what we have to find? We have to find the position of the object when it reaches the maximum velocity. So what is the position of the object? So x equal to 9 t square minus t cube. Okay, we have to find the position of the object when it reaches the maximum velocity, means we have to find the position of the object when time is equal to 3 seconds. Okay, t is equal to 3. So x is equal to 9 into t square, that is 9. So 9 minus t cube, 3 into 3 into 3, that is 27. So 81 minus 27. Okay, 81 minus 27. That is equal to, that is 64. Okay, 64. 64 meter. Equal to 64. Clear? I will tell once again. X is equal to the position of the object is given by the equation 9t square minus t cube. So we have to find the position of the object when it reaches the maximum velocity. So x equal to, so we are finding the velocity v is equal to dx by dt, that is 18t minus 3t square. So v is equal to 18t minus 3t square. So when it reaches the maximum velocity means dv by dt, that is the first derivative may be 0. dv by dt is equal to 0. So that we are finding dv by dt is equal to 18 minus 60. So dv by dt means 18 minus 60 is equal to 0. So we are getting the value t is equal to 3. At the value of t is equal to 3, the function may be maximum or minimum. May be maximum or minimum. So if you want to confirm whether it is maximum or minimum means we can use the second derivative check. For that only we find that is d square v by dt square. Okay, in the second derivative check we get the value that is negative value. So if the negative value comes means it is definitely maximum. Okay, so maximum. So it is confirmed. In that is when time t is equal to 3 seconds, the velocity is maximum. So we have to find the position of the object when it reaches the maximum velocity means we have to find the position of the object at the time t is equal to 3 seconds. So substitute the value of time, that is 9 into t square t cube, that is 81 minus 27. So x is equal to 64